So welcome back. Now that you've seen some of the basic graphs that we typically use in science and biology, I want to show you how to make some of those graphs in Excel to start with. And so this is again our CARS data set. And I'm going to go through how to make a bar graph, a scatter plot, and a pie chart. So let's start with how to make a bar graph appropriately within Excel. So here I've kind of subsetted the data, and we've got two columns. One is horsepower and one is transmission type. Transmission type is categorical. Horsepower is continuous, so a bar graph would be appropriate. We also have transmission type would probably be considered the independent variable, with horsepower being dependent. Horsepower is not going to magically change the transmission type, whereas transmission type could conceivably change the horsepower. And so Excel's kind of funny about bar graphs. You can't just highlight all of this and make a bar graph. In fact, just to kind of show you what happens if you do that, let's go ahead and try it. So if we highlight our whole data and we go to bar graph, we're going to end up with something that looks a little wacky. Every single one of these values got its own bar. That's not what we want. What we want is something that looks more like this one that I've made previously, where we've got each of our categories for our independent variable or transmission, manual and automatic, as separate bars. And so how do we do that? Well, if you recall, a bar graph typically is going to represent the mean of a group within your category. So this right here represents the mean of the horsepower for manual transmissions, and here is the mean for automatic transmissions. So the easiest way to do this is to think back to our descriptive statistics week last week and go ahead and calculate the mean and also the standard deviation, which will come up here in a minute, for both of them. And so to do this, we would want to calculate the mean and the standard deviation for both the manual and the automatic transmission. And so hopefully you remember, but if you don't, to calculate the mean, we are just going to type equals average, and you can click it and it'll open the parentheses for you. Now, since we're interested in the manual, that's where the AM categorical variable is equal to 0. So we want to look at the mean of all of these guys right here where the transmission type is manual. We hit enter. There is our mean horsepower. We want to do the same for automatic, equals average. And now where it equals 1, we want to click and drag. And now we have the average there. Next, we want the standard deviation. And so we want the standard deviation of the sample. And we'll do the exact same thing. Okay, and so now what we're set up with here is all the information we need to make our bar graph. And so what we can do is we can go ahead and highlight both the categorical variable names, so manual and automatic, as well as their means as kind of a little tiny box. And if we hit insert now and we insert a bar graph, we're going to actually get a bar graph that reflects what we're trying to get. So the mean of the manual transmission horsepower and the mean of the automatic. Now we have to do a little bit more here to kind of clean this thing up. One thing you'll notice is that here I've got the standard deviation represented as error bars. And so in order to add those in, your mileage is going to vary a little bit depending on what version of Excel you use, but there's going to be something somewhere around within the chart design tab called add chart element. You're going to go down to add chart element and you're going to add error bars. Now, none of these actually are going to suit our needs. We want to go to more error bar options and we want to make custom ones. And so here you can see the format error bars, and we want to click custom. And we want to specify a value, which we've already calculated. And so error bars can be above and below the bar. In the case of this example, we're going to make the positive error and the negative error, so above and below the mean, the same. And so all we're going to do is we're going to go ahead and click, and we're going to drag across where our two standard deviations were calculated. And go ahead and hit enter, and we'll do the same thing for the negative error bar. Same values right there. It's telling it above and below. And now when we hit OK, now we've got our error bars popped onto our to our graph. Last but not least, we want to give this an informative title, manual versus automatic transmission horsepower. We also want to make sure that we add in our units and what all the axes are. Right now our y-axis, our dependent variable, remains unlabeled. So axis titles, we could here change our primary vertical title to horsepower. And then we could also change our primary horizontal to not just be manual versus automatic as the names of the bars, but also to specify that it's transmission. And so there you are. That's kind of all the steps to make a bar graph with kind of all the essential pieces for you. So now let's move on to scatter plot. Scatter plots are a little more straightforward. Excel does a little bit better with making scatter plots from kind of your raw data. And so here's an example of what we're going to be going for at the end of this. And here's a data set, a slightly different but still cars related data set where we have two continuous variables, so appropriate for a scatter plot. We've got the speed a car is moving in miles per hour. And then we've got the distance in feet that the car has to go before it can stop. So the faster you're going, the longer it takes to stop, basically is what this data set is trying to show. So I'll go ahead and move this graph out of the way. All we have to do is highlight both of our columns. And so we've got our headers at the top that say what they actually are. And we are going to go to Insert, and we're going to insert a scatter plot. And so here we go. We already pretty much have our basic scatter plot. Something that can be a little confusing, though, is that it actually doesn't do a very good job of telling you which one of these went to the x-axis and which went to the y-axis. In fact, I always find myself getting confused, and I have to kind of double check it myself. And so to do that, maybe I'll look at distance and go, oh, this one goes up much higher than speed. Let's see, we've got like 40s and 50s and 80s and even 120 value. And so there's only one axis that actually goes up to 120. And that's this y-axis here. And we've got a point there representing that. So I've just kind of been able to look at the data and infer that Excel decided to make distance the y-axis. You could also just remember that Excel expects your independent variable to be on the left and your dependent variable or y-axis variable to be on the right. It's always good to double check though. Okay, so now all we have to do is really just kind of make this thing a little more informative. Just like on the bar graph, we want to go to Add Chart Elements. We want to add a horizontal label. So this is speed in miles per hour. We want to add, so always making sure we add units. We want to add a vertical. This will be stopping distance in feet, perhaps, maybe meters. And then finally, we want to add a title. So speed versus stopping distance. And that's it. That's a scatter plot for you. All right. So finally, let's say you just want to look at the proportion of your data set of cars that are 4 versus 6 versus 8 cylinders. In other words, you just want count data of a categorical variable. So ultimately what we want to make is a pie chart that represents the proportion of car engine sizes in our data set. And so how do we do this? Well, Excel does not like just being given a list of all of these 4s and 6s and 8s. So we actually kind of have to clean it up and make it look a little bit more like what I have here, where we've got the categorical variable and the count of samples that were within each category. So there were 11 4-cylinder cars, 7 6-cylinder, and 14 8-cylinder cars. And so here we can actually use an Excel formula to kind of help us out here. So if we want to count how many of these cylinders had how many of these cars had 4 cylinders, we can actually say equals, and we can use this function COUNTIF, which will basically count based on some form of criteria. And so we want to first give it a range. So we want to look for things to count within these numbers or cells that I've selected here. And our criteria is that we want to count things that are 4. And so I'm putting it in quotes so that Excel goes, I'm just going to look explicitly for this number 4. And if we hit enter, you can see that there are 11 of these. It doesn't matter if it's sorted or anything like that, although it is sorted here. It makes it a little simpler. And so then we could say 6 and 8. And so this would be equals count if within the same range. But now we want to make it count things that are 6. And then we'll do the last one as count if within that same range, and this time equals to 8. And so now we've got everything we need to make our pie chart. And so what we do is we select all of this, and we can go back to insert, and we can insert a pie chart. And so it's pretty much done. All we have to do is change the title. Proportion of car engine sizes in the MT cars data set, or whatever you want to call it. And done. And so those are kind of how to make the 3 basic graphs in Excel. Again, the bar chart is kind of the trickiest one. You have to do a little pre-processing with your data in order to make it easy to give informative error bars and have the right number of columns.